Okay, let's take a look at page number 3. Question 8 says a small lecture hall has 20 seats in the front row and each row has 2 more seats than the preceding row. Find the total number of seats in the hall if there are 30 rows of seats. So if we take a look at this particular problem right here, the first row has 20 seats in it. The second row has 22 seats in it. Let me put a plus here because we're trying to find the sum of all of these. 22, 24, and so on. And it looks like our difference to get from here to here, the difference is equal to a positive 2. We're adding 2 to get each, to get the next amount of rows, the next amount of seats in the row. All right, so if I want to find the sum of all 30 of these rows, I'm going to go ahead and use the sum formula, which would be n divided by 2 times the first term, a sub 1. Well, they told us we had 20 seats in the first term, plus I need to add the number of seats in the final row, in the 30th row, which I don't know what that is yet, but I'm going to use this formula, a sub 30, to find the 30th term. So a sub 1 is 20 plus the difference is 2 times 30 minus 1. And when I multiply that all out, I end up getting 78. So I'm going to put a 78 in here. And then when I do 15 times 98, I end up getting 1,470 seats. So there are 1,470 seats in this college lecture hall. Let's go ahead and try some extra practice here. Question number 9, find the sum of the first 40 terms of this sequence that's defined recursively. So a different way of defining this sequence. This is our first term. Our first term is -a. And then in order to find any other term, you do the previous term minus 4 on there. If I wanted to find the sum of the first 40 terms, I'm going to use this formula. 40 divided by 2 times the first term. Well, they gave it to us. It's -8. Now I need to find the 40th term. And because it is arithmetic, I can use this formula. A sub 40 is equal to the first term plus the difference. Well, it looks like I'm subtracting 4 to get to the next term, and subtracting 4 and subtracting 4. So our common difference is -4 times n is 40 minus 1. When I multiply all that out, I end up getting -164. So the last term on here is -164. When I subtract these and multiply by 20, I end up getting -3,440 for this. So that one was a little bit different, but I still use the sum formula and the formula to define or to find the nth term in there. All right, let's take a look at number 10. Keep in mind, number 10, I'm still taking the sum of so many terms, but now I'm not starting with 1, I'm starting with n equals 22. So actually, in order to find how many terms I'm taking the sum of, I would take the upper number minus the lower number plus 1. So you guys probably thought it was 33, but remember you have to add that 1 on there. So I'm taking the sum of 34 terms. So I want the sum of 34 terms. I'm going to use the formula. 34 divided by 2 times the first term. Well, in order to find the first term, I need to plug 22 into that formula. So -2 times 22 plus 9. -2 times 22 plus 9 is -35. That's the first term, -35. And then I need to find the nth term, a sub n. Well, n is 34. So in order to find the 34th term, I'm going to plug 55 into this formula. So -2 times 55 plus 9 is equal to -101. So I could do plus -101 on here. When I multiply these numbers, I end up getting 2,300. Oh, go away. 2,312 for that problem right there. All right, and then the last problem, find the sum of the first 500 multiples of 7. So this is giving me a little bit of information right here. I know I have 500 terms, so I'm taking the sum of 500 terms and then multiples of 7. So the first multiple of 7 is 7, plus the next multiple of 7 is 14, plus 21, and so on. So if I want to find I know this is an arithmetic sequence because I'm adding 7, adding 7, adding 7. I would do 500 divided by 2 times the first term we know is 7, plus I need to find the 500th multiple of 7. So 500, the a sub 500 equals the first term plus the difference times 500 minus 1, and that number is 3,500. So then this number right here is 3,500. Add and multiply those numbers, we get 876,750. All right, people.